And right before crashing is unknown estimated project activity times, where you calculate the probability of how much time it will take. Okay, those are the two subjects, and they're the harder two of this whole chapter. But project scheduling with known activity times and project scheduling with unknown activity times, where you're not doing the probability of it being done in a certain time, are so easy today that it's not going to be a big deal. And if you get this, it will help you understand what you're about to face on Thursday. Are we ready? This stuff, this is great stuff. Project scheduling. You will get promoted, and you're going to say, hey, we got this project. We want you to lead it. And if you're leading the project, one of the first things they're going to ask you is, and we want a schedule. And we want a determination as to when this will be finished. You have to put this all together. And in my experience, in my different careers that I've had, I was involved with this a lot because I happened to have been with companies that we were building buildings. And every time you meet with the general contractor, they're planning everything out. How long everything will take. And when this part will be done, when this part will be done, when this project will be done. And so that was really important for me because I had to make sure that the money was going to be there for the project. And when you're doing projects in real life, you're approaching whoever you do your banking with, and you're asking for a bridge loan. You got to work with a bank. You're a credit. Bridge loans still in thirds? Are they still in thirds, or are they variable? Can it be any like fourths or fifths?
I don't think we do bridge loans.
Pardon me?
I said I don't think we do bridge loans.
Oh, okay.
Actually, and I didn't hear any Chase either, so it might not be a thing anymore. It's much more of a push for lines of credit.
You're not, even with your commercial accounts, do you have commercial accounts?
Mm-hmm.
Big commercial accounts, and they never ask for a bridge loan? They're never building a building or anything?
No, it's usually done either through just a straight up loan or a line of credit.
Wow.
I mean, what size are we talking? Are we talking
millions? Every building I've been involved in, I'm borrowing millions of dollars, and I would always get a third to start with. And the deal was, you pay just the interest, which is not a big payment, because you're only paying on the interest on the loan, which is the smallest part of the cost of the loan. Do they have the bridge loans? As you go through the project, the general contractor, and you're meeting with way too many meetings, this is before video conferencing ever existed, and you are getting to a point to where they're about a third of the way through the project, and they're going, okay, it's time for more money. And you then go back to the bank, go out ready for the second of the third, and they transfer to your account. You write a check to the general contractor, who has got all the subcontractors set up, and they're continuing the construction. And then you're still only paying on the interest. You work this all in advance with your bank, where they'll allow you to pay just the interest while the construction's taking place. Because whatever it is you're building, you're going to have to rely on the income it's going to generate to pay the loan. So the timing is so important here. I always used to watch in movies, oh, you got to get this done in time, you got to get this done in time. And I go, well, let them take your time, I don't get it. Why? Until I got to real life and realized, because if it's not done in time, it doesn't start generating revenue, you will run out of cash. And running out of cash, you might as well get fired. You might as well leave your job. If you're in, if you're in charge of the county, in charge of the cash like I was, you have to have enough cash to meet payroll. So planning is what this is all about. Planning, planning, planning. Knowing when the revenue will start, because the date that you selected before this ever began with the bank, all based on this schedule that you're going to learn how to make, is what the bank's counting on for you to start making payments on the principal and interest. So your payment goes from like $1,000 a month or $2,000 a month to $20,000 a month, because now you're paying back the principal and interest, not just the interest. And it's a big deal. And if all of a sudden I'm having to transfer $20,000 every month, and I don't have the revenue from the project that was being built, cash is about to go. And I'm panicking and trying to get lines of credits to cover waiting for this building to get finished because it's running late. Very common thing, the first time you experience it, my accounting majors, when you get to the point of running an accounting office, it's stressful. Because you realize if the employees don't go to cash their paychecks, back then they have paychecks, they go to cash their paycheck and it bounces, you're almost out of business. Because your employees don't care. They only want their money, and they're not coming back, or they're gonna start sitting down and not doing their job and protest that you didn't pay them. and they're going to call the state. And the state is automatically doing an audit to figure out what's going on. This is real life. This is why this is so important. This is project scheduling. Almost any major project in a business, all has to be scheduled, every activity in advance. The hardest part is coming up with the activity schedule itself, meeting after meeting after meeting. But what you're going to learn from me isn't so much how to come up with the schedule, it's what happens after the schedule. And the reason this is so important to learn is if you understand what happens after the schedule, it then helps you realize how to make the schedule, because you're making the activity schedule so it will work when you're using CPM. Excuse me. You ready? Here's the difference between known activity times and unknown activity times, which I changed the word to estimated so you don't get confused. Unknown means you still have activity times, but they're estimated. They're not in stone. I lucked out. Almost all the projects I've been involved in were construction projects, and general contractors know exactly how long it takes to drywall 10,000 square feet. Electricians, they know exactly how long it takes to run all the wiring and put all the plugs and switches in for 10,000 square feet or whatever the building is. So I've worked with known activity times. And here's what they look like. Just jump into this so you can see the difference. See each activity over here, but see this? How much time it's going to take? There's just one number there. Because at this meeting, when this was discussed, they knew exactly this paperwork is going to take exactly 3 days. We know it's going to take. This building the body is going to take 3 days. We know it's going to take 3 days. So that's how it was in my meeting. We know the foundation's going to take 3 weeks. We know the framing's going to take 7 weeks. We know and on and on and on. They knew the times. And so it makes it much easier because you don't have to do the first couple steps when the times are estimated. That's the only difference between these. There's a couple of extra steps when the times are estimated, which is more common for any project that's not a building, where you don't have to do a mixed note. Now, how do you come up with this? Are you ready? I'm going to use building because this is what I have the most experience in, and I can clear mind with this. Let's pretend that the framing just got done. So all the studs are in place. Next after the framing usually is what I want to do drywall, but they're saying, no, you can't do drywall because what has to go between framing and drywall? Anybody has experience watching a building be built? Justin wants to jump right in, I don't know why, but go ahead. Insulation's one of them that I have on my list. What's the other two though? Plumbing, electrical. Now this is what you do when you're coming up with a plan like this. Now I'm starting at framing because I don't want to do a whole long list, but I say, oh, let's pretend this is our first thing. And then you just give it a letter or a number, I give it an 8. All right, and then you say, okay, what's right after framing out of the things that have to be done? There's electrical, there's plumbing, and there's insulation. Well, they can be in any order because none of those three, I take that back. Plumbing and electrical can be done at the same time because electrical doesn't have to wait for plumbing to be finished. They can work at the same time, just in a different area. Plumbing doesn't have to wait for electrical to finish. They can work at the same time in a different area. But drywalling, they have to wait. You cannot put a drywall on a wall that doesn't have the electrical or plumbing or insulation in place yet. So it has to wait, and that's how you come up with these. Here's how it works though. You are going to list what activities out of the list are immediately precede the activity that you're talking about. Let me just start listing activities and you'll see what I mean. I'm jumping with plumbing. Okay. C was electrical. D is insulation. Let's go with E with drywalling. Are you ready? I start at A. Nothing comes before A because we're going to pretend this is the beginning of our list of activities. Plumbing. Can we start plumbing right away after framing or before framing or while framing is going on? No. Matter of fact, plumbing can't start until that framing is finished, and that is the thing that finishes just before plumbing can come in and get started. So I'm going to put A right there. This is the immediate predecessor. I know I'm forgetting something, don't worry about it. Is that what you're gonna say? Yeah, don't worry about it. This is just general. Electrical. Does electrical have to wait for plumbing or framing or anything to be done? Yes. It doesn't have to wait for plumbing, but it has to wait for framing. So the immediate predecessor is the framing for that one. Insulation. What gets finished before insulation gets started? Not the framing. Framing has to be done before insulation, but it's not the immediate predecessor. After plumbing and electrical get finished, insulation comes in. But these two have to both be finished. You can't start insulation when electrical's not finished, even if plumbing is, and you can't start insulation when plumbing's finished, but electrical's not. So I'm going to put both B and C. They're both just before insulation, and they both have to be finished before insulation gets started. Now I'm at drywall. Drywall is after framing, but framing, there's other stuff that takes place before you get to drywall, so it's not an immediate predecessor. Plumbing, electrical, no, they're not right before drywall because we're not waiting for plumbing and electric. Even after they're done, we still got to wait. Insulation. That's what takes place just before the drywall. And so we're putting D as the immediate predecessor there. This is how it takes place. This is how you come up with this. And it's these, the logical sequence that you heard me say out loud, that comes up with these, that makes this work. And if you don't do it with immediate predecessors this way, this will not, you'll get a plan, but you'll finally get to the 6th day in, you go, oh, this isn't right. And you'll go, wow, I just wasted a bunch of time. We got to redo this whole thing. That's why this is so important. The bad news is that the bigger the project, the more the meetings to come up with this. You spend far too much time in meetings, wherever employer you go to. If they don't do a ton of video conferencing, you are the one to convince them to do it, because the amount of time you're going to meetings and coming back, and coming back, and the BS that takes place in between meetings is just too much wasted time. All right, here's our first example. Remember, this is micro. How many activities do you see? Not all at once.
8.
Thank you. 8 activities. You can see the immediate predecessors. Obviously, you start, there's nothing that precedes it. Building a body, you gotta have the initial paperwork done. As soon as that paperwork's done, we can start building the body. Building the frame, as soon as the paperwork's done, they can go at the same time even. Finish the body, can't get started until building the body gets done. Finishing frame, can't get started until building the frame gets done. But final paperwork can't get started until both finish the body and finish frame gets done. Now notice, build body and build frame are not part of the immediate predecessors because, yes, those do have to be done before you do final paperwork, but not immediately before you do final paperwork. These are the ones that are right before it. Well, I'm sorry, hang on. These are the ones, you're right before it. I just contradicted myself. This is what I meant. Mount the body is these two. Now this last one, install a skirt. You don't have to wait for the final, or you don't have to wait for the final paperwork. You don't have to wait for the mounting the body or this or this. As long as the frame is built, starting to be built, not finished, you can then do the skirt. All right. These are known activity times. Let me show you if you see a problem with unknown activity times. And in real life, we do start estimating how much time do you think this will take? This isn't a building, because they always know the answer to that. Some other project. How much time do you think this will take? One person to me will say, oh, 2 days. And the brother will say, I think 3 days. Well, then you start using a range of numbers that are right around what everybody's consensus is as the time the activity will take. And it looks like this. Jumping forward to slide. Whoops, hang on. Right here. This is what it looks like for a project that has estimated activity time. You come up as a group with 3 possible times. What's the shortest we can get this done? It's called optimistic because you want to get this project done as fast as possible so it's generating revenue. What's the shortest this activity could get done for this project? What's the longest it can take, and what will most likely be the time? Now, in this case, it's right between the two, but that's not always the case. Hang on. I gotta find one that's not right between the two. G. Here we go. Thank you. G, where's that one? Well, yeah, you're right. 1.5, 1. So that you think this would be 2, but it could. If things don't go right, it could take 5. It could 5 units of time. In this case, hours. You will see 3 numbers there. soon as you see you're not given just one number of time, you got to say to yourself, uh-oh, this is not known activity times, this is estimated or unknown, all you're reading in your PowerPoint, unknown activity time, meaning they're estimated. And when they're estimated, you have these steps first, right here. You take the most probable time, the one in the middle, and you put 4 times the weight to that one. Give it most of the weight. You add the other two, the longest and shortest amount of time, the optimistic and the pessimistic time. But the weights on the most probable. You're using 6 numbers. 4 of them just happen to be the most probable time is all. Then the longest and the shortest. You divide by 6 to get that average. Now you just changed estimated time into a known activity time, and you do that for every activity, and then you flip back to solving it just like you're going to do with known activity times. It's this extra step to convert estimated times to known activity times. All right, and if you're not doing a construction project, most of them are estimated activity times with this range. And then you have tons of meetings to narrow it down. All right, how do you solve them? What does this all mean? You ready? We'll go to our example. This is a fine float business. They make floats. They have a parade coming up. The crew has a new float. They want to schedule it. You know, there's only 8 activities, so, but you know, this is just a micro example. There's usually 50 activities, not just 8. The table on the next slide shows the activities that comprise of the project. Their activity, it says estimated completion times, but they're actually known completion times because we only have single numbers, which means at that meeting they said, I know this is going to take 4 days. I know this is going to take 3 days. Frank wants the total time to complete the project. That's what needs to be known. After, what is the expected time this project will be completed? When you have known activity times, you can come up with almost an exact amount of time. Here it is again. This is what it would look like. Then you take the activity and you draw a network. You will not have to draw the network for this class on a quiz or your final exam. All right? If there's a network involved, it will be given to you. But let me show you how this was drawn. Look at the activities. If it has no predecessor, it's coming from the start. And then you start looking at, we just made A. What does A precede? Okay, it precedes B and C, no others. You put next to A, B, and C. You draw arrows from A to B and C. Okay, what comes after B and C? Okay, D does, E does, F does, and H does. You place them and you get the arrows in place. And then what comes after that? G and F. Something like that. And it looks like this. Here's the start. A had nothing preceding it, so it's at the start, right after the start. B had A before it. C had A before it. So we got those two. D had only B before it, but F had both B and C before it. So we got an arrow coming from both of them. E had C before it, but so did H. So we have C going to E and H, and F also had C. So we have C as a immediate predecessor for 3 different activities. G has D and E before it, and any activity that doesn't precede another activity means it can go straight to the finish when it's done. When that activity is done, it's done. It doesn't precede another activity. So what do we have going to the finish? F, G, and H. Notice F is doesn't precede any activity. G doesn't precede any activity, and H doesn't. And that's why the arrows go to the finish. All right, don't let me lose you. This is where you got to wake yourself up now. We're doing what's called a forward pass. This is manually how you would figure out what the activity time will be for this project. Are you ready? This isn't going to be hard. It's just at first you're going to freak out a little. Don't worry about it. I got it. You ready? Except I didn't have this turned on. Now I got to dance. I'm going to this one to get started. Whoop. Oh, this reminds me. Darn. I posted a new spreadsheet. I added, since the last quiz, I added 1, 2, 3, 4 rows. I put the weights. So all you got to do is enter your scores, and this should be exactly what it says on the weighted total, if this spreadsheet's working correct. Don't forget, as we get to the end, a whole bunch of you are going to start emailing, hey, what do I need to get a B? What do I need to get an A? Just create some more rows and just start estimating your own, you have all your scores in but your final exam, just start putting scores in for your final exam and watch that change. You'll know what you need. Okay? Anyway, are we there? Let's take a look. Here's how it's done. We got the drawing. This box is the letter of the activity. That box is how much time that activity is going to take. These are known activity times. If these were unknown, you first get to turn them into known activity times, and then you put them in the box. You don't put those in until you convert them to known activity times. Now they're in the box. Here's the forward pass. As we go forward, we're only using the top two boxes for every one of these activities. Just the top two for forward. You ready? A is going to start on day 0. It takes 3 days, so that means it's going to finish on day 3. Got it? Now that A is finishing on day 3, its immediate predecessor of other 2 activities that can start the day that finishes. So B starts on day 3, C starts on day 3. B is going to take 3 days. Is that right? 3 days. So it will finish on day, now you can start helping me. 6, thank you. C takes 2 days, so it will finish on day 5. You got it. Now let's go to D. D is only preceded by B, which finishes on day 6, so D starts on day 6 and finishes on day 9. You got it. F. Uh-oh. Uh-oh. Well, hey, what? Wait a minute. It could start on day 6, or what is this? 5. It could, but they are both immediate predecessors, which means F cannot start till they're both finished, which is the bigger of the numbers that precede it. You could have 3 activities before, 4 activities. If they all have to be finished before that activity starts, you've got to find the biggest number, the latest of the activities. So C's on day 5, B's on 6. We have to use the 6. So I'm going, what was that, F? Starts on day 6 because they both have to be finished. Finishes on day 9. E starts on day 5, finishes on day 12. Is that 12 or 13? 12. 8, 9, 10, 11, 12. Thank you. Just making sure. Alexa's not here. G. Here we go. You got 2 activities. I hear 9 and 12. I'm the only one saying 9. All right. So G's at 12 because you had a choice between 9 and 12, and you've got to pick the larger number as you go forward. The reason I'm emphasizing larger number going forward, it's a good time to write your notes. When you're going backwards, it's always the smaller number. You're going to have these same exact scenarios going backwards, but you pick the smaller number, not the larger. You'll see in a minute. Okay? So now I'm on activity H. Only has 1 preceding it, so it starts on what day? 5. Finishes on what day? 7. Have I got? Well, what about G? What day is that finish? 18. Okay. Every activity has their top boxes done, right? Now look at any or all the activities that go to the finish. The finish is going to be the completion of this project, which can't be completed until every activity's finished that lead to it. So we have 3 different numbers there. I see a 9, a 7, and an 18. What's the project time for this project?
18 days.
18 days. That's the project time. This project should take 18 days according to our plan. You're ready to get started. You know the completion time, the loan set up for 18 days. If this were a really big project, blah, 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 blah. You have it. Now, as someone who's a very conservative financial person, I don't trust this, or whoever has programmed this. There could be an error. So when I'm negotiating the loan, I always give myself a cushion. This will direct you towards what you need to do, but experience will lead you to the real best solution, which is leave yourself a cushion. Arrange that loan's first principal and interest to be, if this is 18 days, I'm going to tell them probably 21 days to make sure I have a cushion, because I've never been involved in a project that's gotten done on time. I've never experienced it. Because there's humans involved. As long as there's humans involved, something's going to happen, and nothing is not going to be on time. Are we good? We got a forward pass. Everybody see how to get that completion time? Okay, now we're doing a backwards pass. Backwards pass always starts at the finish, and anything that was right to the finish when going backwards has to have the bottom right-hand box, which is called the latest completion time, has to be at the full completion time of the project. So there's 3 activities that went to the finish: G, F, and H. They're all going to be in 18 because they're the first ones from the finish. So I'll put an 18 in the bottom right-hand box of H, 18 in F, 18 in G. Now, let's start with G. Subtract the amount of time G takes and tell me what the latest start time will be. How many days? What day? On what day? I'm sorry. On what day could be the latest they start? Take 18 minus the time G takes.
6.
So 12.
Oh.
There you go. Now let's go to H. H could finish as late as day 18. It takes 2 days. So it could start as late as, there you go. Now let's just talk about those 2 activities we just filled in. Notice one of them has different numbers top and bottom. One of them has the same numbers. Your focus, your career, if you're ever involved in a project, is all about the activities that have no gimme, that have no buffer, that have no room for human error. That G activity must start on day 12, must finish on day 18, or this project is going to be delayed. And as we go backwards, every activity that has the earliest start and the latest start at the same number, it will also have the earliest finish and the latest finish will be the same number. And you can subtract either one of them, the start to the finish, and what will be the difference? How much is the difference? 0. You just identify a critical activity. Now, in my experience, building a building, knowing how much money's on the line, and what could happen if this gets delayed, every critical activity I would always focus on. I would just go, okay, can you give me the name of this subcontractor right here for this one, and this one? And the general contractor was understood completely, knew I had responsibilities that are very large financial responsibilities, and would say, this is the subcontractor for this one, subcontractor. I get their phone numbers, and I'm calling them the day before they're supposed to be there, or even 2 days before. And I'm saying, look, activity G, I just want to make sure we're getting close to day 12. You know, if you don't make it on day 12, you're delaying the whole project. This is very important. I literally get involved in contact subcontractors that are on the critical path, it's called. Because that is, look at H. Look at the difference here. How much is the difference? How much slack, is called slack, exists in activity H? Either subtract the start or the finish, you get the same number. How much? 11. We have 11 days cushion. I'm not calling activity H. They could start on day 5, and I never tell them that they could start on day 16. I'll never tell them that because they won't show up until day 16. They know that they're not a critical activity, and they're supposed to start on day 5. I won't contact them. Either they're showing up on day 5 or they're not. I'm not going to stress over it because if they're not there on day 5, it's not going to slow this activity down. If they don't show up on the next day, it's not going to slow activity down. Matter of fact, they don't have to really, I don't have to start sweating and having nightmares until we get to day 15 and 16. At that point, if they don't show up, the whole project's delayed. That is a non-critical activity. I let someone else handle it. You know, I know there's a big cushion there. I don't have to stress. Critical activities is what you're identifying by doing this. You ready? Let's keep going backwards. F is 18 minus 3 takes us to 15. Tell me if it's critical. Slack is how much? 9 is the slack here. All right. So far, this is our critical activity. E. Here we go. E has G after it. The latest G could start is a 12, so that means this needs to be finished by day 12 at the latest. 12. But you subtract 7, it starts on day 5. What is this? You just found another critical activity. E, that's the one we're focusing on. There's a human involved, which it most likely is. They cannot be late. You've got to have some kind of communication on day 4 and 3 and say, look, day 5's coming up. We're counting on you. If you're not there, it costs money. That's when I learned to put delays in the contract to get reimbursements for the delays. Okay? Because when you experience a delay and you run out of money, you guys emergency get cash on a line of credit, you start to learn, look, this wasn't my fault. I now need to have the contractor. If you want to be the general contractor, do you guys realize how much the general contractor makes on these deals? 10%. It's a $2 million building. The general contractor gets $200,000 for hiring all the subcontractors and making sure things go smooth. That's their job, planning it all out. Just making sure you realize. All right. D. What activities are after D? G. What's the latest G could start? So D could finish as late as 12. Subtract 3, we get what? Is there slack here? How much?
3 days.
3 days. Don't have to worry about that. Let's go to, what have we done here? We're just B and C. Let's go to C. Okay, here we go. C, real quick, what's the latest it could finish? C.
5.
How much? 5? No. Maybe. You're right. What numbers are you looking at? Tell me the numbers you're looking at. What?
5 and 6.
I see a 5. I don't see a 6. You're looking at a 5. What else?
3.
Not a 3. A 16 I heard. Yes. 15 also. This is the latest start for this activity. This is the latest start. So we got a 15, a 5, and a 16. If this doesn't finish before every one of these 3, there's a delay. So it has to finish either by 15, 5, or 16. Remember, going forward was the largest number. Justin, I think, jumped on it. The number going back is the smallest number. So I don't realize that was just pretty much it. So 5 is your answer here, not the 15, not the 16. This activity has to be done by day 5, or it's going to slow down. We'll see here. This activity, and if it slows down this activity, the whole project's slowing down because now that's a critical activity. By the way, what is this? 5 minus 2. What did we just find? Another critical activity. All right, let's go to B. What is the latest B could finish? 9. You looked at 2 numbers, which were 9 and what? 15. You pick the small one. Not, as long as B finishes by 9, D will be able to get started. F will get started. Right? So that's the latest it could start. What's the latest it could finish? Excuse me. What's the latest it could start? 6. Is there slack in this one?
3.
3 it is. A. What is the latest finish for A? 3. What was the other number you were looking at other than 3? 6 or 3. You went with the smaller, which is 3. Subtract 3. 0. What's this activity? Critical. Notice, if you are in the planning stages of a real project, you should always notice when you do the forward and backwards pass that you have critical activities that are chain linked together from the start to the finish called your critical path. Does that exist at this one? And what is that path? A, C, E, G. There's your critical path. The critical path is so important to identify because when we get to estimated times, it's all about that critical path to figure out probabilities of the project being done in a certain amount of time or less, or a certain amount of time or more. We're heading towards stats. I can feel you guys going, oh, stats, what? Oh, how can we even talk about it? How do we feel? Could we do a forward and backwards pass? Let's confirm it real quick. Boom, boom. Here's our network. Here's our forward pass, 0, 3. This starts at 3, add 3, 6. This starts at 3, add 2, 5, right? We get to the end. The end has a 7, an 18, and a 9, so that means the project's completion, expected completion time is 18. We head backward, put 18, 18, 18. We start heading backwards. It looks like this. 18 minus 3 is 15, 18 minus 6 is 12, 18 minus 2 is 16. Odds are, you are either going to be doing a forward or backwards pass in your future, and it's not that hard, but you write notes on the decisions that you have to make when there's more than one activity involved in the direction you're going. That's the part that everybody starts to screw up is, should I be going with the larger number or the smallest number, especially when there's 3 or 4 activities before or after. We got this, right? Okay. So now, you put it all in the either the software, and you come out with this. This is what it looks like. And it's the same thing that was in your forward and backwards pass. A, earliest starts at time 0, and it could finish on day 3, but it could start as late as 0 and finish on day 3. It has 0 slack. We just identified a critical activity. B starts at 3, because it's after A, it precedes it. It takes 3 days, so it could finish at 6, but it could start as late as 6 and finish at 9 and not hold up this project. So it has a slack of 3, it's not critical, and so on. The same information's right here when you got your output. Then right below all this information, you'll have this. It won't have all these words. It will say this, critical path. It will give it to you. But on the quiz, you've got to tell me. And then it will tell you the expected completion time. If you're doing this for estimated times, the software will allow you to enter all 3 numbers instead of just 1, the range. And so there'll be one more thing here, and it will be the project variance. Everybody hear that? And the reason the project could variate is because you didn't come up with actual for sure time. You came up with a range of times. It could be this amount of time or that amount of time, or it could be written somewhere in the middle. And that's why it could vary. Now, what I want to point out is that that variance is calculated by the critical path only. This is how you come up with your variance, because it's the amount that these critical activities could vary from amount of time that causes the variance in the project. The other ones have so much slack that they could vary and not have any effect on the project. All right. You ready? Go right here. You ready? Number 7, right? Project management, right there. How many activities did we have? These are known or uncertain activities. These are known, right? We had 8. Is that correct? Open it up. Here's 8 letters there. Starts out, you're on A. The amount of time A takes is 3 days. Now you click on B, all of a sudden you'll see A show up here because it's asking you, click on A if it happens to be the immediate predecessor of B, just in case. And B may not be preceded by any other activity, so you wouldn't click on anything. But in this case, A is. So I'll click on it. Notice it shows up over there now as an immediate predecessor. And B takes 3 days. Let's go to C. Now, the previous activities show up in this column over here. You can click on one of them, 2 of them, and so both A and B precede C. This is where you go, wait. Anybody's saying C? What? What? Look how easy it is to fix. There we go. That's what I wanted to show you. All right. D. What precedes D? B. Just B? Thank you. So I just click on B. I forgot to put the time in for C. Okay, go back to C. How much time does C take? 2. D. How much time does D take? Is it really 3? And then I have the predecessors right for D. Is it only by, and then let's go, I want to get to F so you can see what's here. E is preceded by just C, I guess. And it takes 7 days. Is that right? That can't be right. Does that say 7? Yeah. Okay, here we go now. F. F is preceded by both B and C, so I'll click on both B and C. And see how they both appear, and then you put the time. You just keep going like that. I'm almost done. I might as well keep going. So you can see how the output looks. I'm looking at time. What time is this class at? 10 minutes? Yeah. Really? Darn. Let's jump to an output. Yeah. Look. Boom. There it is. Now hit solve. Those are the right activity times, right? Yeah. This is what your output will look like, just like you saw on the slide. There's your activities. There's the critical ones. Here's the critical path. A, C, E, G should be a yes next to A, C, E, G. Here's the expected time. And then there'll be the project variance when we get to estimated times. How do we feel? I want to keep going for these last 10 minutes because what I'm about to say is on the video, but I want you to hear it twice. Just, let the video be kind of reviewed for the first few minutes. What I want to show you now, again, if we're doing estimated times, a range of times is what we use 3 times. The middle time will be the most likely times 4. Then the shortest and longest amount of times get added. So there's 6 numbers divided by 6. Just 4 of the numbers happen to be the same number. It's just putting more weight to the most likely time. There were 6 parts. 4 of the parts are on that most likely, and then you have 1 part on each of the other 2. Divide by 6. So this is how to do the variance. I'm going to come back to this. Better do it right now. We're running out of time. When you have estimated times, you calculate the variance. Now, I've seen students start calculating the variance for every activity because of maybe the problem was asking for something like the probability of this or that. You do not need to calculate the variance of every activity. Only, ready? The variance of a project is the variances of the critical path added together, and that's it. You do not need to find the variance of any other activity but the critical path. And to find that variance, you say, okay, here A, C, E, G, right? A, C, E, G or something. You go to activity A and you say, what was the longest amount of time that was estimated for that activity? What was the shortest amount of time? Let's subtract them, divide by 6, then square it. There's the variance for that activity. Go to the next critical activity. Let's say C. What was the longest that should take? What was the shortest? Subtract them. Divide by 6, square it. And then when you have the critical path variances, which let's say there's only 4 of them, you add the 4 together, you found the variance of the project that is using estimated times instead of known times. That's when the variances are involved, when you're estimating the times instead of known. And they'll always, in this whole class, you'll be given 3 times that each activity could take. And it looks like that. Right? Here's our drawing. Again, in real life, you should figure out how to do this, but you don't have to. And for this class, you'll be given this if this is involved. All right? Boy, I know you guys could do a forward pass on this, right? All right, just checking. Here's our expected time and variances for every activity. Which activities are our critical activities? Very good. Now, for those who didn't get this, they were looking at the amount of slack in any activity that has no slack, meaning the earliest start and earliest finishes at the same time, latest start, latest finish at the same time, are the critical activities. And then you go back and you say, are all these activities on a path? One may not be, but usually they are. And there's your critical path. So what was it? A, C, F. Look at the drawing. A, C, F in the line. Do they touch each other so far? Yeah. F, and then the next one is F, I and K after F. Does F lead to an I, and then does that lead to a K? Yes. Then that's your critical path. That all those activities are exactly on the path. So there's our critical path. Now look at the variances of your critical path. I gotta look at it again. A, C. So, oh, darn it. A, 4 nights. C, 0. What's the next one? F and I. Again, F is 1 night. I is 1. And then the last activity. You add them together. A, C, F, I, K. The expected time will be those last ones that go to finish. Ends up being 23 units of time, hours in this case. You add the variances of the critical path, and there's the project variance for estimated time. This project is expected to take 23 units of time, but it has a variance of 2 units of time. Square root this. It has a standard deviation of 1.414 units of time. All right, this is it. Damn it, 4 minutes. Ready? I won't. This is where I really, really want to review stats with you, because I know a lot of you hated it. You ready? This look familiar? All right, don't worry, you're going to love stats. Here's another way of looking at this. This number line, we're going to say that changes, not this bell curve. We're not going to make this skinnier and wider. The bell curve we're going to leave just like it is, but we're going to keep changing this number line. Here's how you change the number line. The middle is always your mean. In this case, your expected time, which is how much time is this project supposed to be? I believe it's on there. 23 units of time, hours in this case, there's 23. Now, empirical rules say that you go out about 1 standard deviation and you got about 68% of your bell curve. You go out 2 standard deviations, you got about, I can't remember, 90%, 92%. And you go out 3 standard deviations and you have about 98% of your bell curve. All right? So you put your standard deviation marks there, and then you add 1 standard deviation, that's the number you put there. You add 2 standard deviations, you put that number there. 3, the numbers get bigger, like you're looking at a number line. Subtract 1 standard deviation, subtract 2 standard deviations, subtract 3 standard deviations. There's your number line. Now if I put a line right here, and I shaded to the left of that line, if you had to tell me a percent of the bell curve area underneath it that's shaded, what percent would you say? 50%, because that's the exact middle. And all of these tables in your book are always telling you the percent of the shaded area to the left. So what's the standard deviation? So 23 plus 1.44 is 24.144414. There's that one. Then I add another one, subtract 1, right? So here's the deal. If I said to you, this is going to take, what's the probability it's going to take 24.414 units of time or less? You would calculate Z, and it would basically be telling you what the number is that represents the amount of shading to the left. My question for you is, this question asked, what's the probability that this project will take 24.414 units of time or less, when usually it takes 23? My question for you is, should the answer be more or less than 50%?
More.
More. You all agree, because you can tell now by looking at this where approximately 24.414 units of time or less will be. Now, when you look that up in your book, it's always the probability being given to you from any of these spots or less. If I asked you, what's the probability that this project is going to take 24.414 units of time or more, you got to do the same calculation as if I'm asking for less. You look it up because the table always gives you any of these times or less. But I asked for more. So whatever you just found for the probability, subtract it from 100%, and you just found your more. So you're always doing these type of problems for less. But if the question asks for more, you do the opposite. 100% minus what you just found. I know we're out of time. How much out of time are we? We're completely out of time. This is about 5 minutes into the video right here. And I'm going to go over this all again on that video and start showing you how these probabilities are calculated, how you find them on the table, and then when you subtract them from 100%. That's where this video goes. All right, where's that piece of paper with everybody's first name and their email?